Hello guys, welcome to problem 2. It turns out that I started talking and working and have been going on for 5 minutes without recording. I'll just tell what I did. First, these congruence groups, all being subgroups to gamma. When we take the projection modulo n, we end in subgroups of the special linear group of the congruence field modulo n. This guy maps to unity, this guy to these n matrices, this n subgroup, and this guy to a somewhat larger group. And S lies here, but not in any of these, because this equals unity. Or is it minus unity? I forget. We'll just check. Yeah, it's unity. And the guy up here is minus unity. So S lies here, but not in any of these. T lies up to this one, where b is equal to 1, but not in this one, but t to the nth does, of course. So that was the note on the congruence subgroups of gamma that I wrote in the explanation, in the text of the first problem, first video that I would just comment upon. Next, I started on to A. Project SL2 to the special linear group of set modulo n set. And let's say this guy lies in there. That means that it's this matrix has determinant 1 plus some factor of capital N. And then I wanted to say that one of these had to have no common divisor with n. And then I believed I would be able to tweak the coefficient. Say if A had no common divisor with n, then I would be able to tweak D with a multiplum of n so that I could make this guy vanish. Now that I think of it, it's not so simple. We need like two. Well, on the other hand, D1, actually AD may have a divisor D1 and BC a divisor D2 of n, but they can have no common prime divisors. So the greatest common denominator of that's not divisor of these two is unity. Oh, and this way we may go on. That sounds very good. No, it doesn't. Because if we change one of these with a multiplum of D, then it won't be equal to the same one in this group. So that idea didn't work. And that's when I decided that I would make a break. And that's when I discovered that I wasn't even recording. So I'm back to making a break. I have my coffee now. I'm not quite sure though that I explained my thinking correctly, so I'll just work a little more on it. My idea was that if A and B had no common divisors, then we can tweak D and C with n and use like D plus xn, C plus yn, and then making this give unity. So we want this to be unity it's AD plus AXN minus BC minus BYN, that should be a minuscule y, which equals, this equals 1 plus n. A and B have no common divisor, then we can solve this equation within the integers, and then we have actually found our matrix. As a counterexample, while the coffee was brewing, I found the matrix 3.3.0.6 modulo 17. And here A and B have the common denominator 3. And the determinant is equal to 1 modulo 17. And of course, tweaking this modulo 17 will, well, I don't know. Could that be? I think it can't be done, obviously, because this will always be a factor of 3, so we cannot make it vanish. So that was where I stopped. And that was where I thought that they might have distinct divisors of 17, and this need not be a prime, that could be any integer. It just turned out this way. So we need to change A and B by factors of 17, so that these have no common divisor. And here it's easy, I can just subtract 17 from 3, or add 17 to 3, so we get 20.6, and then we can solve it like up here. But then I need to prove that adding multiplies of n will actually result in some guy being and that's where I need this thinking, but it's not quite clear how I can do it. So that's where I'm still a little unclear. So if we just add n to it, I feel it's a very simple trick when I've discovered it, but so are most of the problems here of the book. Let's just do the program here, and let's say we take 3 and minus 14. That is 1 plus 17, and then we have 3 times x minus plus 14y equals 1, which we need to solve. And we can take y to be -1 and b to be 5. And x this is the guy to be multiplied. That's 5 times 17, that's 105, plus x, it's 111. And naught minus 17, that's minus 17, that's 333, and that gives 28, and 2 to 11, that's 13, that's 233. So that didn't really work out. But now you have the idea I'm working on. A few hours have passed, or maybe 3, but I think I've solved the problem. And even though it's in the middle of the afternoon where the light is too bright to make a good recording, I look terrible, I just wanted to show you what I've discovered. There was a mistake here, and then this mistake, you should be -1, so this is the right solution. Now, the example with 3, 3, we can actually always use, if A and B have a common divisor, we can always use A, let's make that black, oopsie, A and B plus n or minus n, whatever you want. Because if they have a common divisor, oh, that could be some other divisor. Huh. I just thought if A, B, and B plus n have the same divisor, then it would divide 1 as well, so it had to be unity. But A and B plus n might have another divisor. So actually what I have to do is to compare all of the divisors A and B plus in and see what could they possibly have in common. Now let's wait a bit with that problem and then look at the rest. So we take this special linear group from modulo mn to modulo n, and that's a little strange to me because we have set projects to set modulo mn set, which projects to set modulo n set, and the projection, we call this P1 and this P2. The projection from set to the bottom one is just P1 combined with P2. And this is onto by definition, so of course this one is onto. And this holds for the special linear group as well. The combined map is onto, and this is onto. So take whatever gives this one and project it down here. Its image will be what we look for. And finally, with the general linear group, is not where we should start. In the general linear group, that means the determinant lies in the multiplicative group, so let's say the determinant is A of our matrix. Can't call it M, so let's call it X. Then we just make a new matrix, Y equals the inverse of A times X. It lies in the special linear group. It can be lifted to this special linear group and then multiplied with a lift of A, and we're home. So all we need to show is that an element in here has a lift, invertible element in here has a lift in this larger group. And that means if an equals unity, they have no common divisor. Then might this one have? Of course it could have n. All right, so there is something to show here. This is not obvious. All right, that was what I had this afternoon. Well, guys, it's now Sunday, the 10th of December. This problem turned out to be surprisingly difficult. So we have A and B and capital N, and we need to add powers of n to this and this guy and show that they can be made mutually prime. I've ended by, we call this A and B and N, of course. And the greatest common denominator of A and N are called dA. The greatest common denominator of A and N. And we do the same with B. Then we look at the arithmetic sequence. A divided by dA plus I times N divided by dA. These two guys are mutually prime, which means that this progression will hold an infinite number of primes, so we can choose some prime. Pi A. That means that A plus INA equals dA times this prime. We do the same with B, so we get B plus JN equals dB times some prime. And as already mentioned, we know that dA and dB are mutually prime. So now we want to choose these primes PA and PB, so that these two are mutually prime. The two primes must not be the same, and I believe that's quite possible, that two progressions will have a lot of primes, maybe an infinite number of primes in common, but there are enough to choose from, so we can just choose two distinct. And then we must choose them so that they are not equal to any of the primes occurring in dA and dB. There's only a finite number there, so that should be easy. And this means that we can now choose representatives here that are mutually prime. None of these prime factors are the same. This turned out to be quite technical and surprisingly so. So if you can find an easier way, please write in the comments, because going this way was surprisingly advanced. To use so much technique, is that really necessary?